Hello everyone, today we are participating in Codeforces educational round 124. This will begin after a few seconds. Exactly one of them means the winner of each of the pair advance to the next stage and the athlete who has defeated gets eliminated from the tournaments. The pair are formed as follows. In first stage, athletes 1 compete with athletes 3 compete with 4. Second stage, winner of 1, 2 compete with the match of 3, 4. The next stage is when the athletes XY competes, the winner is decided as follows. If X plus Y is odd, then athletes with the lower index wins. This X is less than Y. X wins. X plus Y is even. The athlete with higher in the following picture describes the tournaments for n equals to 3. Athlete 1 athlete. So 1 plus 3 plus 7. The tasks of the following: 1. Determine the index of the athlete who wins the tournament. We have to find for the overall n. So we can easily do brute force. We have to find the winner. Which number will we go in the end? N is up to 3. For n is equal to 3, there are 8 athletes. For n equals to 30, there are 2 power 30 athletes. So, either we only have to, either the first will be win or either the last will be win, which will depends on the event. The first sum of 1, 2, 3, 4, 2 power n and 2 power n minus 1. These are the odds. These are odds. Second one will be odd, then lower index will be. Then always 1, 3 will come here, and here alls are odds. Here 2 power n minus 1 will come. So these all are odds. Then odd plus odd is even. Then the higher will be win. Means 3 will be win. 3. 2 power n minus 1 will be win. So higher will win and lower will win. If n is odd, the first one is always 1 for n equals to 1, 1, 2. N equals to 1, 1, 2. Here for the third tournaments 1, 3. This is even, so here 3 will become, and here 2 power 7 will become greater, even sum greater. Then again we have only the first one we have even sum, only the first one we have odd sum, then after that all the players will always have even sum, means always 7 will be the winner. So only for the n equals to 1 1 will win, otherwise always answer will be 1 left shift and left shift minus 1. So moving to the other problem. Accepted. Prove him wrong. Recently your friend discovers one special operation on an array recently your friend discovers one special operations on an integer array A. Choose one of the following spaces. Recently our friend discovers one special operation on an integer array A. Choose two indexes I and j. We have to choose two indices I and j, I not equals to j, and set ai equals to aj equals to difference ai minus aj, their difference. After playing this operation while, he came to the next conclusion: for every array A of n where A is 1 sitting over 9, we can find a pair of indices I comma j such that the total sum of A will decrease after performing the operation. This statement sounds easy to you, so that you want to find the counter examples for the given integer n. Can you find such counter example and prove him wrong? In other words, find an array A consisting of n integers, all pairs, that for all pairs I and j, performing the operation would not decrease the total sum. It will increase or not change the sum, means sum will not change after performing. Length. Here you perform the operation index 1 comma 2 or 2 comma, you will get 1/366, then array will become this. In both case total sum increases. Oh, here the total sum increases. For n greater than 4, n equals to 2, I think for the limited n the answer will exist. Recently your friend discovers an special operation on an integer array. Choose two indices I, ai aj equals to difference ai minus aj. After planning the operation, he came up to the next conclusion: for every array E, n with integers, now you can find the pair indexes I comma j such that total sum of A will decreases after. You can find the statement is false. You find, so you want to find counter example for the given integer array, and can you find the counter examples, or we have to prove him now? Means for n equals to 2, it is possible to make n equals to 8 always possible. For n equals to 2, it's always possible. See, for n equals to 2, a minus aj. means here we will take here we will take these two numbers are same. A minus AJ, both will be set same. So one number will 1, other number will be n. Then both number will be n minus 1, n minus 1. Sum increase. For the third one, if one number is 1, another number is 2, another number is 4, another number is 4, and if we subtract these two numbers, if we take 3 here, if we take 3, then 1 minus 2 will be equals to 1. This will be 1, this will be 1, this sum is going to be decreased. So if we take here 4, 1 plus 4, 5. So take for the 1, 3, for 1 and 3, 1 minus 4, 3. So here 2, here will be 2. Sum is constant. A minus b equals to a plus b. A minus b minus a plus b. So this sum is constant. 3. If we also take here 3 plus 3 comma 4, 3 comma 4 will be decreased the sum to 1. So what's the sum we can get? 3. For to get 3 to the 6, 7. Here will be 7. Then 3 plus 7. 3 plus 7 will give you 3 plus 7. 3 plus 7 will give you 7 minus 3 equals to 4. If I take 6 here, then sum will be 9, and 3 minus here it will be 3, here it will be 3. 3 plus 3, 6. Sum decreases, wrong. So if we take 7 here, then 7 minus 3, 4. Here 4, here 4. 4, 4, 8. But sum here also decreases. So if we take 3 comma 7 or 3 comma something which is more, 3 comma 8. If we take 3 comma 8, 3 plus 8 is 11, and 3 minus 8 is 5. 5, 5, 10. Take 9 here, 12. 3 minus 3. If we take 9 here, then it will be 3 minus 9 is equal to 6. 6 comma 6. 6 plus 6, 12, and 9 plus 3 equals to 12. So 12 will be the perfect, means the square of that number. I think pattern will be repeated in a square manner. 1, 3, 9, square of a number. So for the minimum one, I will prefer to choose, can I take 2, 1 comma 2? Is this will be give me wrong answer. For 1 comma 2, for 9, the 9 will next make the 9 9s are, if 9 and 3 are 27. If we here take, if we take 10 here, then difference will be 1. If we take 20, so 9 minus 20 equals to 11. 11 plus 11, 22. And here the sum is 29, which is perfect. So if we take 27, so 9 minus 27, 9 minus 27, 18 to the 36, 36. It are 36, and 9 plus 9 for the 36, constant, 36 sum is constant. So sorry, I think the sum is always the pattern type. Pattern is of square numbers. 2077 means the pattern is a square. So another example, say if is 26, then 9 minus 26 will be 26 minus 9. 26 minus 9 into 2, 34. 26 minus 9, or 26 plus 9, 35, and here we have come 34, which will be less, means square, again a square. So then again multiplied by 3. So the longest number we can get of take a, how much number they have said, take about 9. So now I'm into v dot back. All multiply by 3, all multiply by 3. Why I'm getting wrong here? Oh. Why this type of output? 1, 5, 3. Please God, accepted, wrong answer 2. Oh, accepted. Nice. Moving to the Moving to the problem C. So we have guessed the pattern correct. So there is a classroom with two numbers. There is a classroom with two rows of computers. There are n computers in each row, and each computer has its own grade. The computer in the first row has grade A1, A2, AN, and the second row it has B1, B2, BN, A1, A2, AN. Initially, all the pair of neighboring computers in each row are connected by wire. Initially, each pair means I and I plus 1 for all, and so on. So two row from two independent computers. Initially, all pair of neighboring computers in each row are connected by wire. So two rows form a two independent computer networks. Okay, that's correct. Your task is to combine them in one common network by connecting one or more pair of computers from different row. Your task is to combine them in one common network by connecting one or more pair of computers from different rows. Okay, connecting the ith computer from the row in the jth computer cost AI minus AJ, AI minus BI. So connecting them will cost this much, and you can connect one computer to several other computers, but you need to provide at least a basic fault tolerance. You need to connect computer in such a way that the network stays connected despite one of its computer failing. In other words, if the computer is broken, no matter which one, the network would not split in two or more parts. What a minimum cost to make a fault tolerant network? We have to make a fault tolerant network. First integer t, then first line of each test is constant integer and number of computers in each row. Second line will be this, and it is guaranteed that n is for each test print the minimum total cost to make the fault. In the first case, it is optimal to connect 4 pair of computers. First, here connect 4 pairs of computers. Computers 1 from computers 2 cost 3. Computer 3 is from for computer 2 cost 3. Computer 2 from computer 1 10. I have not understand the problem statement. I have to read it once again. Your task is to combine them in one common network by connecting one or more pairs of computers from different rows. We have to combine them in one common network by connecting one or more pairs of different rows. Connecting the ith computer from the first row itna cost. You can connect one computer to several other computers, but you need to provide at least a basic fault tolerance. You need to connect computer in such a way that the network stays connected despite one of its computer failing. Despite one of its computer failing, and In other words, if one computer is broke, no matter which one, the network would not split in two or more parts. Oh, we have to make that connection despite this one is broke, means here 1 2 3 these are connected. Here we have to make a star network 4 5 6 4 5 6, okay, 4 5 6, and we are connecting computer 1 to computer 2, this one again, then connecting computer 3 to computer 2, this one, then computer 2 to computer 1, this one, and then computer 2 to computer 3, this one. Okay, so it's a zigzag pattern, and upward one is if this one fails, network is still single. If this one fails, these are also connected. So we have to make 1 2 3 1 2 3 4 5 1 2 3 4 4 edges here, 5 6 7 8 9 9 edges here, 9 edges here. So we have to make a that connection that whether this can be cross this type, AI minus AJ cost will be taken and sum of this cost will be there. For the second one, this will be only cross connection, and for the single line connection, what will be the output? This, 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 this. So we will sort the array. If we sort the array, and for the maximum to maximum, minimum to minimum subtraction, max 1, max 2, max 3, max 4, max 4, max 5. Simply answer. We will try to take only differences. We will try to take the difference of what's the sort. My sort is on here. Sort is. Oh, I'm taking two overloads. Okay, this was the correct answer. Answer will be ABS of A of I minus B of I. This connection will never be faulty whenever the failed. Here the answer is 31,7. Is it necessary to connect the last two ends? Connect the last two ends. One, 10. 1, 10, and is it not necessary to connect the last ones? Because if the break, that will be always there. 22. Here the last cell are 20, 25. if 25 fails, then it will be connected to this one. So there will be two possibilities, either this one or the cross connections. For this one, let's make some new paper. A 1 2 3 4 5 1 2 3 4 5. If we left this from this cell, this cell, this cell, okay, then if this one is failed, this is going to be disconnected, so we have to join also this. So we have to join this one. So we have to join this one to this. Then it will always join. If this one, this one always join. And for the cross pattern wise, this pattern, this pattern, this pattern, this pattern. Okay. And for the this pattern, this pattern, this pattern, this pattern, cross connection, we have to make this. For the line connection, this. So we have to subtract this one and this one for the above side. So here I'm calculating answer, and RES equals to, should be raise RES equals to ABS of I minus AB of B plus 1 plus ABS of B of I minus ABS minus A of I plus 1. I plus 1, all here will be subtraction sign, and in the final we will take the minimum of the answer is equal to minimum of answer comma RES about the answer comma RES. So this will give me a C. Oh, 31 and 998. Why is it so? 998. This one come here, that. So this one minus with this one minus with this. Solve the problem. 31 solutions. But only the output here. And what can be the output? $490 submissions. See, so we have to make minimum cost, so that whenever a computer fails, it will be connected. So what will the minimum cost? this one is joined, this one is joined. So we have, so first we have to make so much edges that the network is connected. Here I am joining two edges. It can also be possible that this connection is more better than if we join by two, then this one join, this one make a pair that if this one fails it will be also connected. If we subtract a minus b, a minus b, a minus b, only two differences here we are taking upon. Only two edges are we are making. So what are those two edges? 1, 2, 3, 4, 5, 6, 7. Only two edges are we are making. So we are joining this one. Joining this one, this fails. This one. Just submit it because I do not get any other idea of joining them. Wrong answer. I know that. So I also do not have idea how to approach this problem. What can I do now? So right now, so now I'm moving to the solution part, only being able to solve two problems. So going to the first one, play off. So in the first problem we have given two about n athletes, and these are the patterns in which they are going to play, and if the x plus yth is odd, then lower indexes will win, and if the x plus y is even, then the higher indexes will win. So the observation in this problem is that the x plus y odd condition will only exist for the first tournaments which is going to be held here. After that, all the elements that comes here will always be even, because these are always odd elements. All the even elements are eliminated here, because here always pair will be with odd and even, and odd plus even is always odd, so the lower one means the odd one always come to the next tournament. So the answer, the athlete 1 is going to be win only if n equals to 1, otherwise it's always the higher athletes with the higher index value win. So in the final round, always the athlete 2 to power n minus 1 athlete 2 to power n minus 1 athlete will win. So this is the main observation in this problem. For n equals to 1, print 1, or otherwise it will be 2 to power n minus 1, shifting n times the left bit here. Moving to the second problem, prove him wrong. So here we have to generate the sequences such that here we have to give an output, an array a1, a2, a3, a4 something, such that we perform this operation I and j. The sum of the elements after the performing this will always be either be greater than the previous one or will be equals to, and it will never be decreases. Here they have defined that condition, means we have to find such an array that after performing this operation sum will never be decreased, means the total sum of a decreases after performing the operation. So we have to give a counter example of this case. So the counter example will only be exist here. I have taken the best example for the value number 3, and if I take the value number 4, then the maximum size I am making will be something 4 ka power x will more firstly will exceed the 10 to the power 9 limit. So I am taking the case for the 3 that will give me more elements in this array of that the array we are creating of this subsequence. And the pattern, if and for the n equals to 2, if we take, then 1 minus 2 will always 1 comma 1, so it will always be less than. So it only possible to make the best case for the n equals to 3. So here I have first I am filling the vector for the n equals to 3, and if I take the previous elements multiply of 3 comma 9 comma 27, then 3 minus 9 will be 6, and here is 6 plus 6 12, and 9 plus 3 12 constant, 6 minus 18 9 plus 27 36. So here the sum will always be constant in the case of the 3. So 3 is the best to give the counter example. A counter example is valid only if the vector size is greater than equals to, and means the some limited size we can create it and simply printing the vector. That's all for the second problem. Have a good day, and bye. We'll solve C after the contest.